Okay, so we're at the start of 5.2, probability rules. It's our first lesson. So in this section, we use simulation to imitate chance behavior, right? So that's what we've been doing. We don't always have to do simulations to determine the probability of an outcome. Sometimes we can just use probability. So a probability model is a description of some chance process that has two parts. A list of all possible outcomes, we call that the sample space, and the probability for each outcome. Sometimes those are equally likely outcomes. I guess sometimes it's not equally likely, but what are the probability for each outcome? A sample space can be very simple or very complex or have just a few things in it or a whole bunch. So if you were rolling two dice, this would be the sample space, right? Every possible outcome. You might get snake eyes, that's 1 and a 1. You might get double sixes, that's 6 and 6 together there at the end. So there's 36 possible outcomes, if that makes sense. Notice order is different here. So like in the second column, there's a 3 and a 2. In the third column there's a 2 and a 3. So those are two different outcomes. Order matters in this case. The sample space, you're putting every possible order of rolling two dice. What are the possible outcomes? 6 times 6 is 36. There are 36 possible outcomes. Since dice are fair, each outcome is equally likely. Each outcome has a probability of 1 out of 36. So each one of those would have 1 out of 36 probability. So what is the probability model there? You would write out the sample space, and then you would say each outcome has a probability of 1 out of 36. An event is a collection of outcomes. So let A equal the sum of a 5 when two fair dice are rolled. So if you look at all the possible outcomes there's 36 of them. How many of them give you a sum of 5? I'm just looking through the first column of two dice there, and 4 and 1. Add up to 5, 2 and 3 and 2 in the next column, add up to 5, 2 and 3 in the next column, add up to 5, and 1 and 4 in the fourth column, add up to 5. So I find 4 different cases where the sum is 5. So that's 4 out of 36, which it can be simplified to 2 out of 18 or 1 out of 9. So you have a 1. We say that probability of A means the probability of the first event, in this case A, happening. So P means the probability of the occur. Probability of A happening is 4 out of 36 or 1 out of 9. So sometimes you have equally likely. If that's the case, you can just use a formula. It's a very simple formula. Success on top, number of outcomes to event A, the total number in the whole sample space on the bottom. So these are rules that a valid probability model must obey. So if they're all equally likely, all outcomes, in this case, rolling a die, yes, that's true. The probability of that event occurring is, again, the number of outcomes in event A divided by the total number in the sample space. The probability event is a number between 0 and 1. That does include 0 and 1, and when it says between there. All possible outcomes must have probabilities that add up to 1. That's actually true. We're going to talk more about that in a minute. But there's different ways of looking at that, but that's true. In fact, that's probably, when it says, is this a valid probability model, number 3 is probably the first one I look to. They love to change. Maybe the probabilities don't add up to 1. And, well, that's not a valid probability model. And we'll talk about how to check that. The probability of the event does not occur is 1 minus the probability of the event occurring. That's called the complement of an event. So A of C is the complement of the event. It's kind of like the opposite of the event, if you want to think of it that way. The event that A does not occur. Okay, so rules, again, these same 4 things. Nothing's really changed there. You have to rewrite that down. Okay, if we roll 2 fair dice, what is the probability that the sum is 6? So looking at all 36 possibilities, sum of 6 would be 5 and 1 in the first column, 4 and 2, 2 and 4. Wait, no. Third column, it would be, 3 and 3. Fourth column, 4 and 2, 2 and 4, and then 1 and 5. So there are 5 different possibilities. So 5 out of 36. If we roll 2 fair dice, what is the probability of 5 or 6? I think we already figure out the probability of getting a 5. I think that was 4 out of 36. So you're just going to add those 2 up. So when it's like this or that happening, in this case, you're just adding. There's no overlap we have to worry about here. So it'd just be 9 out of 36 or 0.25. 2 events, A and B, are mutually exclusive, disjoint, if they have no outcomes in common, so they cannot occur together. The probability of A and B both must be true is 0. So let's just try that with 5 and 6. What's the probability of rolling a 5 and a 6 with 1 dice? That's impossible. You can have a 5 or a 6, but not both. So that would be, those are mutually exclusive events. They're called disjoint. The addition rule for disjoint events is you're literally just going to add up the 2 probabilities. That's what we just did. We took the probability of 5, rolling a 5, and the probability of rolling 6 and added them up. This rule works only for mutually exclusive disjoint. It gets complicated when there's overlap, and there was no overlap there. Again, this is more clear. I like the way they said it there, between 0 and 1, including 0 and 1. S, we call that the sample space in this setting. The probability of the sample space must equal 1. It's a weird way of thinking about it, but those are all the possible outcomes. In the case of equally likely outcomes, it's the number of successes or outcomes in event A, whatever you're trying to get, divided by the total number of outcomes in the sample space. The complement rule is the probability that A does not happen is 1 minus the probability of A happening. An addition rule, if they are mutually exclusive, you're just going to add them if it's an or statement. Okay. Suppose you tear open a quarter bag of M&Ms and observe the color. According to Mars, probability model is this. You see this color probability model, so evidently blue is 20.7%, orange is 20.5%, slightly lower. Is this a valid probability model? So what you would need to do, get this a little smaller, is I'm going to add up those numbers in my calculator. So I'm going to go to calculator page, type in 0.207 plus orange is 0.205, green is 0.198, plus yellow is 0.135, plus 0.131, plus 0.124. And we get exactly 1, right? That means that's a good sign that this is a valid probability model because we added up all the outcomes and they added up to exactly 100%, right? 19.8% plus 13.5%, etc. adds up to 100%. Because they add up to 1, that is a valid probability model. Find the probability you don't get a blue M&M. So the probability of blue is 0.207. So the complement is all the others added up. You could either add up all the rest of the other ones or just do, the formula is 1 minus the probability of blue, 1 minus 0.207, there's a 79.3% chance. That's going to be a lot faster if you can think that way and do the opposite or complement of the event. What if you want to get an orange or a brown? So orange is 0.205, brown is 0.124. Are those 2 events mutually exclusive? Yes, they are. They cannot happen at the same time if you pick out one M&M. And so you're just going to add those 2 up. That's what our formula says, 0.205 plus 0.124, which is 0.329. Okay, let's just look at a couple of problems. So Principal High School has 3 shirts to choose from, white, blue, and black. 4 ties, red, white, green, and blue. One morning after storm, there's no electricity. He chooses outfits from the closet of the dark. I think I've done that. In other words, he is randomly picking a shirt and a tie. Give a probability to write out the sample space and probability of each outcome for the samples. So sample space. So probability model means we want a sample space, but that's every possible outcome, right? So we could just talk it through. White and red, like as in white shirt and red tie. White and white, that would be a little strange. So white shirt, white tie, white and green, and white and blue. So 4 that start with white, 4 that start with blue. Blue red, blue white, blue green, blue blue. 4 that start with black. Black red, black white, black green, black blue, right? So there's a total of 12 possible outcomes there. And so again, we listed out every outcome, that's the sample space. And because all those outcomes are equally likely, we would say there's a 1 in 12 chance of having one of those outcomes. Okay, define A as the outfit, has a matching color shirt and tie. Okay, so how many times out of those 12, if you listed those out, would you circle and go, those have the same colors for both days, like for shirt and the tie? And so that would be, there would be white, white, and blue, blue are really the only options. So there's 2 out of 12 different outcomes, so about 17%. Okay, Buffalo Wild Wings ran a promotion called Blaze and Bonus. With every 25 gift card, you get a bonus card for either 5, 15, 25, or 100. Wow. Company here, the probabilities, I like this promotion. It's kind of fun. I mean, it's a small chance you get a $100 gift card, but like you're getting something extra in addition. So I like this. Explain why this is a valid probability model. If you add up the 0.89 plus 0.098 plus 0.010 plus 0.002, it adds up to 1. It is a valid probability model. Find the probability you don't get a $5 bonus when you buy a $25 gift card. So I would do 1 minus 0.89, whatever that is, would be your answer. It's a complement using the formula. What's the probability you get a $25 or $100 bonus card? So those seem mutually exclusive, so I'm just going to add up the 2 probabilities. So 25 is 0.01, 100 is 0.002, so that'd be 0.012, I believe. You're just adding those up. Okay, that's your lesson for today.